Hey there, you nines, Mr. Herman here. I hope you guys enjoyed your holiday break and welcome back to term 4, our last term for the 2021 academic year. And what a year it's been. This is exercise 5G, applications of quadratics. Learning goals of this lesson is to know how to apply the steps for solving a quadratic equation, to understand and check the validity of solutions in the context of the given problems. That learning goal is just based on negative or positive answers, which we'll delve into a little bit later on. And the success criteria for this lesson is to be able to set up a quadratic equation from a worded problem and to obviously be able to solve that worded problem. So applications of quadratics, all the prior lessons that we've looked into, we're going to apply those skills and we're going to be tackling worded questions. Now, we've already tackled worded questions before. The only difference with this is that we're going to have quadratics involved, or in other words, we're going to have some form of x or some variable to the power of 2 involved. Okay, the highest power will be 2. So some key ideas before we tackle this example that we have here, and there's only one example. When applying quadratic equations, you're going to follow these steps. You're going to define a variable or a letter. Generally it's x. You're going to write an equation from the context, solve the equation, so try to solve for x, and then choose a solution that solves the equation and answer the question in the context in which it was given. So just write the answer in worded format and check that the solution seems reasonable. Now, I was talking about positive and negative solutions. You will get scenarios where you can stumble across one negative and one positive answer, and when you're dealing with trying to solve a question that, which you will see here, has to do with length, it's a bit tricky to look into negative length because we're talking about real life context. So just keep this in mind. Check the solutions seem reasonable. Just make sure that the solution that you get makes sense. Generally, it's a positive solution, positive answer that you get. So example 18, in the only example here, we're going to find the dimensions using quadratics. The area of a rectangle is fixed at 28 squared meters and its length is 3 meters more than its width. Find the dimensions of this rectangle. In other words, find what x is. I'm going to give the variable x. First thing we're going to do is we're going to draw a rectangle. So we know that this rectangle here looks like a trapezium. This is a rectangle. We know that this here is equal to 28 squared meters. Okay, so we know that the length times the width will give us 28. Because that's the area of a rectangle, length times width. Now, its length is 3 meters more than its width. So we don't know what the width is. So this right here, this we can deem the width. Okay, so this here is the width, and we'll deem this as an unknown variable, which we'll call x. We don't know what this is. And we know that its length, so this length here, is 3 meters more than the width. So if it's 3 meters more, it's whatever the width is, which is x, plus an extra 3. So this here is our length. So area is going to be equal to length times width. And in this case, we've defined our length to be x plus 3 and our width to be x. So our area, this is going to be equal to x plus 3, which is our length, multiplied by whatever the width is, which is just x. Now, we know what our area is. The area is 28 squared meters. It says it at the start of the question. Yeah, it's fixed. So I'm going to just rewrite this, but in a bit of a neater format. I'm going to put this at the start, and I'm just going to write it in this format here, x bracket x plus 3. We generally don't have this times x next to it, so we'll put the x in the front, and we'll multiply that by x plus 3, and this is going to be equal to 28. And all we're simply doing now is just solving for the width. find the dimensions of the rectangle, solving for the width, which is x, and then using that information to solve for the length. Okay, let's expand this out. Okay, so we want to get rid of these brackets. So using the distributive law, the x gets multiplied with the x. That's where we get an x squared. So here's a quadratic nature of the question. X times 3 is plus 3x, and this is equal to 28. So that's our first step. Now we want to make this equal to 0 in order for us to solve for x. In order to do that, I want to take away 28 on both sides. This will cancel out to 0, and what we have on the left hand side is x squared plus 3x minus 28 is equal to 0. And here we can now solve. So we're going to look for, so I'll shoot this across here, whoops. We're going to look for two numbers that when multiplied together will give me negative 28, and then when added together will give me positive 3. And the two numbers that I can think of is positive 7, positive 7 and negative 4. So positive 7 and negative 4. And this is equal to 0. So when we extend this out again, we should get back to this original format, x squared plus 3x minus 28. So two numbers when multiplied will give me negative 28. I know one of them has to be a negative in order for this negative 28 to happen, and one of them has to be positive because the coefficient in front of the x is a positive. It's a positive 3. So we know now that x plus 7 is equal to 0, or x minus 4 is equal to 0 because of our null factor law, meaning that x can either equal negative 7 or x can be equal to 4. So this here, this step here, we're so just by routine can get to this solution here. But you got to remember that this is a worded question, so we've got to remember the context. What is it that we were initially trying to solve for? Is the fact that we're trying to find what the width is. Okay, so what this width? We've defined the width as our x, and yay, we have found our x, but we can't have a negative 7 length for our width. It doesn't make sense. So a more suitable solution for this is this x equal to 4. So this is suitable to the context. Okay, and I want you to make sure that you don't go into autopilot and just say the length can be either negative 7 meters or 4 meters, because you will lose marks if you're suggesting that a length is negative. Okay, so just be very, very careful with the context of the question. So now we can write, therefore the width of the rectangle is 4 meters, and we know it's meters because it's in squared meters, this solution, as we can see when Photoshop is, there we go, we can see here it's squared meters, so we know that the context has to be in meters, or the unit rather. So the width of the rectangle is 4 meters, and the length is 3 more than that, which is 7, which is length is 7 meters, because based on the diagram and based on the question that we got, length is whatever the width is plus 3, and we know what the width is, it's 4 plus the 3, which is 7. So the width of the rectangle is 4 meters and the length is 7 meters. Double check, 7 times 4 gives me 28, and that's a solution to the question. So this is the only example that we'll be tackling for this exercise. You've just got to recall when you're tackling the questions, All of them are in worded format. Just be familiar with the formulas for area. Rectangle, pretty easy, and triangle as well. If you need a recap, you can always use Google just to double check what the formula is, and make sure that you make sure you choose the answer that is suitable to the context of the question. All right, try to avoid negative solutions unless there's a little indicator of some sort that says within the question, which you'll rarely see anyways. All right, that is this exercise done and dusted. Remember, the weekly planners can be found within the first lesson of the week within 901 Maths. You'll be attempting questions 1 to 6 from exercise 5G, and the extension questions are question 8, 9, and 12. 12 is quite tricky to understand it at first when you read it, but once you understand what's going on, it's actually quite a simple question to answer. But if you need a bit of clarity, if you wish to tackle the extension question of 12, by all means, you can ask me. All right, best of luck, guys. I'll see you in the next video.